Hi guys.
And go on, the stage is yours.
Okay. So hi guys, so like it was said, my name is Tomasz, and I have got the pleasure today to speak to you about DevOps and microservices in Amazon and AWS in general. So for those of you who don't know me, I'm a solution architect at Amazon Web Services. I have been working there for a bit more than 2 years. Before I was a developer, solution architect at a lot, Accenture, a bit in IBM. And now I'm helping companies, to build, to design application system which will run in the cloud. So the agenda for this session is quite simple, to be honest. So we have got two main topics. The first topic is the Amazon DevOps story. So this will be a bit more theoretical chapter of this session. So I will describe you how it happened that Amazon went from standard monolithical system application and it get this DevOps culture and it went to microservices architecture. Then the second chapter, the second topic of this presentation will be microservices in the cloud. And here I will focus more on what AWS has got, what is offering to different companies, developers, to build application systems using microservices. So let's start from this first topic, so the Amazon DevOps story. So most of you probably, when you will hear Amazon, you will think about the shop. So the shop where you can buy anything. Books, computers, sport equipment, maybe horse mask. If you need it, you can find it there. Probably you need it. Maybe you don't know it, but you need it. So this is the place how Amazon born, so the shop. But currently, and also some of you may know Amazon because there are really big data warehouses. Also in Poland, there's a couple of those. So those are the places where when you are ordering something from Amazon, they are wrapping the packages and they will send it to you from those places. But in fact, Amazon now is much, much more. There are different kinds of sub-companies which are doing different things for different customers. Of course, there is the Amazon shop, so the retail, but there is AWS, so Amazon Web Service, or there is also the Amazon Echo, so the artificial intelligence in the cloud which can help people, to look for information and so on. So for example, there outside of this room, there is people from Amazon Development Center in Gdańsk, and they are helping also to build this kind of technology. So, but let's focus on Amazon. So Amazon, the shop was opened about 25 years ago, and 25 years ago, nobody heard about DevOps, nobody heard about microservices. So whenever a new developer was introducing new functionality, new feature, new something to the shop, it was being added to one big code base and everything was in one single place. And after a couple of years, this code base was really huge. This was multiple gigabytes of code with different kind of functionality, with different kind of features. And there were a lot of developers, and whenever there was a new functionality, it was being pushed to this one single location. There was this one delivery pipeline, so the code was built, it was tested, and it was pushed to production, where we had this one monolithical big application. And everything worked at the beginning, but as Amazon grew, as the application was bigger, there was a lot of disadvantages of this kind of approach. So currently, of course, less and less companies are building applications using monolithical approach because it has got really a lot of disadvantages. It's really difficult to scale. So when we have got one single code base, one single server, and we want to scale only one function, one subset of functionality in this application, we can't do it because we can scale all of them or nothing. Secondly, it takes a long time to test, to build, and release new functionalities. So probably a lot of you works for different kind of enterprises. So Probably you are aware that very often enterprises have got this kind of life cycle of developing new functionalities that they are saying, okay, so the next pushing something to the production will be in 1 month or in 3 months. So it really takes a long time to build something, to push to the production, and to see it actually working. Secondly, because we have got this one big thing, it's really hard the operating thing is really hard. Whenever something is not working, it's really hard to say, okay, whose fault is it? Was this the fault of this functionality, this feature, this team, this person, and so on. And this kind of disadvantages, there's a lot of them. So that's why Amazon decided to move from this monolithical approach to more modern approach architecture, and it was about 15 years ago. So now we used to have this one big one single delivery pipeline, and now we have got multiple different pipelines. And because we have got multiple different pipelines, we have got also different microservices. So now everything should be easier. So this is the picture of Amazon, the shop, the retail, the architecture, which was taken a couple of years ago. So each of those points in the diagram is a microservice. So currently there is really hundreds of microservices which are creating the shop, the retail, so the place where people are buying products. Each of the service is single purpose, so it's providing one single functionality for the e-commerce site. They are connected to each other through API. So when this approach was created about 15 years ago, it was really hard to distinguish between SOA, so service-oriented architecture, and microservices. So in Amazon, we use both of those terms. Of course, they are not the same, but very often they have got the same meaning. So again, if we'll go to Amazon.com shop and we'll look at the page, each of those functionalities, so that we see the picture, that we see the description, that we see the price, is provided by different kind of service which is working in the cloud. So this helps us, to introduce functionalities, new services, new features much more quickly, because we are not looking at, what are doing the other teams, but we can work independently on our features. So for example, when there is, this 5-star rating, so we see that, if the horse mask is rated, 1 star or maybe 5 star, this is provided by separate feature, separate service built on Amazon. And maybe this service, maybe this functionality won't work, things happened, so then it shouldn't affect the whole system. It shouldn't affect the whole website. So in short, because we have got many different small components, small microservices, we can scale better because we can scale those services independently. And because we can focus on each of them independently, we can make sure that our application is more fault tolerant. So like I said, currently at Amazon, there are hundreds of services, which are, sometimes they're really small, sometimes they're really big, depending on what kind of things it is providing. What is also important that everything is being developed at the same time. So different teams, which are working on different functionalities, different features, are not looking at each other. If we have got a team who is developing the star feature, the star microservice, they are doing this in the same time when the other teams are doing the price service or the picture service. So one of the most interesting thing about Amazon, and Amazon is known from this, is the concept of 2 pizza teams. So Amazon decided, those 15 years ago, that each of the team who will be working on its own service, on its own microservice, it shouldn't be a big team. So this should be a team who can be fed by 2 pizzas. So this will be more American pizza, so quite big one, not European. So usually it will be about 8 up to 10 persons. So we have got teams, 8, 10 persons, who are building those microservices. And they have got a full ownership of what they are doing. So it's not only that they're developing the code, they're developing the microservice, and after this they are just pushing it to the repository and saying, okay, we have done it, test it, publish, and it's up to you. No. So if we have got a team who is building the microservice, they are also responsible for testing, they are also responsible for pushing this code to the production, and they're also responsible for fixing the problems on the production. So it's really full ownership. So they need to make sure at the beginning that the thing which they're doing is proper, and there won't be any problems with this. And so it's really a DevOps culture. So it's not only, okay, let's develop something, but let's think about the whole process from A to Z. So, and also one of the key features, key characteristics of this approach is the self-service. So whenever a new team will build a new service, it will be provided to others. And it's self-service. So a different team who is building a different feature, different functionality, can start using this, this first functionality, this first microservice, without saying to anybody that, yeah, I'm going to use it. There is a microservice for this, there is an API for this, you can start using this. Also, which is quite important, is technology agnostic. So in the past, and still a lot of enterprises are doing something like this, that they are saying, okay, so in our company, we will use this technology. So we'll use only Java, because we don't like .NET and so on. We'll use only this framework, Spring, and so on, and so on. And with Amazon, the approach is a bit different. So every team, because they have got the full ownership of what they're doing, it's up to them to choose the technology. Of course, there are some best practice, we know which technology works where, when, but if the team thinks that, okay, this new technology which just came to the market is good for this thing which we are currently building, if they want, they can use it. So that's why, of course, at the end, there are different technologies used in Amazon, but at the end, it provides the freedom to the developers. They're happy because they are not stuck to this one single technology, this one single programming language which was created 15, 20 years ago. They can try, they can test different new things. So, of course, which is connected with this is, why are we doing something like this? Depending on what kind of service, what kind of functionality, what kind of feature we're doing, there are different kinds of requirements which we want to meet. Of course, there are functional and non-functional requirements. So let's focus, for example, on non-functional requirement. Maybe we are building a service, a functionality, a feature, a microservice, which is really important for us, and we need to make sure that the latency is really low. Or maybe we are building something, but the latency is not important. It's more important about the recoverability, or maybe about the durability of the data. So each of the cases is different. So whenever the team is building something new, depending on their needs, they need to check what kind of non-functional requirements they have got. And depending on this, they might choose different kind of service which they will use, for example, for storing the data. So it's not like, okay, we are saying everybody in Amazon needs to use MySQL because this is open source. It's good, it's fast. Yes, everybody will use MySQL. No. If you are building a service, a microservice, you want to provide a functionality, a feature, and the latency is really important for you, use a service which will be the best for you. Maybe this will be MySQL, maybe this will be Aurora, maybe this will be a data warehouse, maybe this will be a cache in the cloud, or maybe S3 and you will store the data there. It's up to you because you have got the full ownership. So because we have got those different teams who are working at the same time on developing those functionalities, we have got continuous development. And all those teams are pushing into productions all the time, small things, small changes to the production. And so small statistics about this. So currently there are thousands of teams, thousands, in fact, microservices in Amazon. And the designed architecture is microservices. there is this continuous delivery. So all the time we are pushing new things to the production. So we are not waiting 1 month, maybe 3 months to push everything at the same time to the production. And we have got, of course, multiple environments. So at the end, in average, there is about 50 millions of deployments every year only on Amazon.com. So I'm not counting the cloud itself, just the shop. So 50 million deployments. So what is, of course, important in this, in this DevOps culture is the experiment and iterate. People shouldn't be afraid that, they will experiment. Maybe it will work, maybe not, but they should experiment and they should try and iterate to make those things better every time. So also one of the key functionalities whenever we are building something new is this concept of MVP, so minimum viable product. So whenever Amazon is, or AWS in fact, is building a new service, new functionalities, it won't be, perfect. It won't, provide you 100 of things which you expect from this functionality. No. At the beginning, it will be really simple, At the beginning, Amazon will provide you only the core functionality which you expect, which you need. And after this, we will iterate. Maybe it will turn out that, you will give us feedback and you will say us, yes, it's going in a good direction, but, there should be something new about which we, as Amazon, didn't thought. So then we will get this feedback and we will push it to the production, we will develop those things, and we will also, put this on the production. So small changes, iterations, and building, one week, every 1 month, adding new things which people are expecting. So I guess most of you should know this diagram, this picture, and this is, the concept of, building this MVP product. So it's not about, okay, we are building a car. So let's first focus on building and delivering the wheel to the user, because the wheel, he won't do anything with this, The second approach, if we're building the car, but at the beginning we'll build a bike, it also, it doesn't make a big sense for the user. So maybe, we're building the car. So let's build the car at the beginning, but maybe without engine, We'll be just pushing this, but the basic API, the whole structure will be there. So the user will know, okay, what to expect from this functionality. So they know, okay, now there's no engine, but probably in 6 months there will be engine. And if not, we will tell them, okay, so this is a good thing, so just add engine to this. So iterate, iterate, iterate. So again, a bit of statistics. So at average, a new deployment on Amazon.com, there's every 10 seconds. So every 10 seconds, there is something new on Amazon. Of course, sometimes it's a really small thing, We are just doing some A/B tests. Sometimes this is much bigger, deployment, depending on the situation. So again, depending on the situation, sometimes the deployment will be affecting a couple of servers, but sometimes it will be, one big, massive deployment, which will be happening on, thousands of servers in the same time, depending, again, of the requirements. And only small fraction of those deployment will make really huge problems on Amazon, because we're using this microservice, approach, and we want to minimize the possibility that something will go wrong. And when something will go wrong, it shouldn't happen that, the whole site is not working. Because Amazon.com is selling products. When Amazon.com won't work, people won't be buying products, so Amazon won't earn anything. So whenever there is a problem with a service, we should minimize the impact which it has got on other microservices. So if we are developing this, this 5-star rating functionality, if it won't work, okay, people won't see how many stars, this horse mask has got, but the whole site will be still working. And of course, the house monkey, so the concept which was created by Netflix. So Netflix is on AWS. The whole Netflix is working from AWS. And a couple of years ago, they have decided that we need to make sure that we are prepared for the worst. So maybe we have got our application which is running on servers, and maybe something can happen wrong with the server. Now it's working, now it's not working. So they started to build those scripts which they're running, during business hours. And those scripts, they are doing is just eliminating, terminating, for example, services, servers, and so on. So this helps them, to identify the places in their application where there are some problems. So, and when they see that, so the script terminated a server component, and the whole application is not working, they will fix this to make sure that their application is fully fault tolerant. So they have got a couple of different versions of those scripts. One of those versions is the House Gorilla. So House Gorilla is really the biggest script. So in this case, they're evaluating and they're testing that the whole region, so the whole data center of AWS won't work. So for example, and of course, AWS also has got sometimes problems and it's affecting a lot of customers. So for example, if the whole data center, the whole collection of data center at Amazon and the region is not working, Netflix will still be working because they are using multiple regions and they are prepared, they have tested their environment, their application to be resistant to this kind of systems and events. So the second topic of this chapter, or the second chapter of this session, is microservices. So in this chapter, I will focus more on what AWS, so Amazon Web Services, is providing to users. So of course, I showed you this diagram before. So there are different, sub-companies on Amazon, and of course there is Amazon Web Services. So AWS, the cloud provider, and I hope most of you don't think now that the cloud is just a data center, because still a lot of people, when you will ask them, okay, so what is a cloud computing, they will say a cloud computing is just a data center. It's just a fancy name for a data center which is owned by somebody else, which is lying somewhere, but it's just a new fancy name for a data center. And in fact, cloud is much more. So whenever I'm talking with customers, I'm saying to them, the cloud is a playground. It's a playground of Lego blocks. So you go to the cloud and you choose those Lego blocks, those building blocks, those services, which you will use to build your applications. And of course, there is this one simple, boring service, which is a server in the cloud. And you can use it to build a new application, new service. It will be like in your own data center, but sure, you can do it in the cloud. But there are different also services, different functionalities, different Lego blocks. So maybe you want to analyze some kind of data and you need Hadoop ecosystem. So of course, you could spin up standard servers. You could, go there. You could install Hadoop, Spark, and so on. Or you could just, click on the Lego block, which is with the name Hadoop, and spin up a cluster, analyze the data, and terminate everything. Or maybe you need probably yes, you need to have some kind of database, MySQL, Postgres, Oracle, whatever. So again, you have got this freedom, this choice. Or you will go to server, you will spin up a server, you will log into the server, and you will install the database, or you will just pick up this Lego block, which is providing you the database as a service, and in 10-15 minutes, you will have got the database. There's no bad choice, everything depends on the situation, on your requirements, on other factors, but also it's important to know that the cloud is this freedom, and this is those other Lego blocks. So, okay, so let's go back to our microservices. So currently, we can distinguish in AWS 3 ways of building applications which use microservices architecture. And the first one will be, of course, the standard approach. So we will spin up those boring servers. We'll spin up 1 to 10 servers or whatever. We will log into them and we'll install our application, our microservices, and everything is working. Maybe we'll use Elastic Beanstalk, which is a service which helps to deploy them, but still, it will be around standard servers. Maybe, and this is especially popular now, we'll use some kind of containers, Dockers probably. So most of people now who are using Docker's containers, they are using them to build microservices architecture. And again, you could do this in the cloud. You could use probably Kubernetes or ECS, so the service which is provided by AWS to manage those Dockers. But again, there will be standard servers underneath. There's again there's no magic there. And the last category, for me, this is the most interesting, is the serverless approach. So you are building this microservices approach. You want to develop your application. You want to focus on your application. You don't want to work. You don't want to think about servers. You are just throwing your microservice and saying to the cloud, manage this, scale this, and so on. We'll go deep into this in a couple of seconds. So the first category with EC2, so the standard servers will be quite obvious. We'll spin up a server. So in AWS, it will be EC2, maybe one, maybe two. Maybe we'll use this, we're in the cloud, so we can scale. So we can set up the auto-scaling group. And depending on the number of requests, depending on the number of visitors, we will add and remove servers on which we have got our microservices. Probably we'll have got also some kind of load balancer, maybe from AWS, Amazon Elastic Load Balancer, and so on. So still for most of the companies, this is the standard approach. Yes, we're going to the cloud, but we'll use standard servers and we'll deploy our microservices using standard ways on servers. There is, of course, the Beanstalk, which I already mentioned. So this is a PaaS, a platform as a service, which the aim of the service is to make it easier for a developer, for a company, to deploy the application. So on one hand, we have got our application. We're just throwing it to the cloud, and we're saying, yes, this is PHP, this is Java, this is .NET. It should be running on single server or maybe multiple servers. And you just go through the wizard, and after a couple of minutes, your application is running. There will be on servers underneath, but the whole management, the whole deployment is easier because it's being done by the Beanstalk. Docker's containers, most of you probably are aware of those. I guess half of the companies with who I'm working now are testing containers, Dockers. People believe that this will save a lot of time for them. Developers love the containers, so more and more companies are trying to do this. And of course, you could do this in your own laptop, you could do it in your own data center, but you could do it in the cloud. So you could have one or multiple servers, you could deploy containers, and everything will be working. Probably you will be using some kind of orchestration application system like this Kubernetes or ECS. So ECS is a AWS version of orchestration system service, which objective is that it's free and it should make it easy for developers, for companies to deploy the containers on servers. But of course, with those two approaches, so servers itself and containers, we're still working with servers. We need to think about, okay, who will manage those, who will patch them, who will update those, how many of those we need, how many servers, maybe 1, maybe 10, and so on. And there's a lot of things about which we need to think about. So this is a quote from CTO of Amazon, that no server is easier to manage than no server. And a couple of years ago, I guess 2-3 years ago, maybe 4, this concept of serverless appeared. And at the beginning, people were saying, okay, serverless, what the hell, how could I use this? But now this is really a big trend across different kind of companies, how to build those application systems. And if we'll go, one step behind, and we'll look at the cloud, there are cloud services. Different cloud services, like, for example, EC2, so the server in the cloud. Inside of this group, we have got this managed service. So those are the services like, for example, RDS, so managed database. We're saying to the cloud, I want to have a database. I want this to be MySQL. This should be running on a small server. Please spin up this. And the cloud will provide you with a database. but you won't have access to the database, to the server itself. You only have got the access to the database, but not to the server itself, because it is managed by AWS, by the cloud. Inside of this category, we have got the serverless services. So those are the services where we are saying, I want to have got a database, I want to have got a microservices, but I'm not interested in the servers. Maybe there will be one server, maybe there will be 100 servers, I don't care, give me just the functionality. So there are different services in serverless services in AWS. One of them is the microservices service, which is called Lambda. So why do we need this? Why a lot of people, a lot of developers, companies started working with this kind of services? Whenever we are developing a new system, new functionality, there's of course the development phase. So we're building, we're coding, and after this, our application is ready. We would like to go to the production to show, to the world that, okay, this is what we have created, but we can't because there is this boring stuff, We need to think about, okay, so where we will run it, How many servers do we need, How we will scale it, Who will manage this, and so on, so on, so on. After this, we have got go live. Everything is working just fine. We're on the production, and we would like to focus on developing new functionalities, on this iterating this thing which we have created, but we can't because there is still even more boring stuff. We're on the production, and we need to think about this infrastructure. Who will update the operating system? After all, every 1 month, we should log into the server. We should check maybe there are some things which we should update. Maybe this Linux, maybe this Windows, and so on. We would probably, most of us, would prefer to not do this and focus on building this application. So there's a lot of this kind of tasks which are connected with servers, which are, for most of the people, boring. I'm not saying for everybody, but for a lot of people. So there is this concept of serverless. And in short, it means that we are saying to the cloud, this is my application, here it is, and dear cloud, run it, manage this, scale it. I'm not interested about the infrastructure. It's up to you. I want this to be highly scalable. I want this to be fault tolerant. I want this to be running. I don't want to pay whenever I'm not using this. And this is my objective. This is my requirements. And then the cloud, what it's doing is managing. It's taking this application, is being deployed on the servers, but the user doesn't see this. So the most famous serverless service is, of course, Lambda. And in short, this will be a microservice, but without a server. So in short, it means that we are building our application on standard laptop, like we used to do in before, using a couple of different languages like Java ecosystem, Python, Node.js, and .NET Core. We're developing these microservices. There is one library, AWS library, which we need to include, and then our microservice is ready. And then we're taking it, we're throwing to the cloud and saying, okay, here it is, run it, scale it, and so on. So there's a couple of different characteristics, features about Lambda. One of them is the scaling, scalability. So whenever we have we have thrown this application, the microservice, to the cloud, and it's there, what the cloud will do, it will scale it automatically. So maybe there is one user who is using our application, so there will be one instance of the Lambda. Maybe there will be 3 users. So what AWS will do will spin up, will spin up 3 instances of the Lambda. So all of those users will be able to interact with the Lambda instances. But maybe there will be thousands of them. Maybe there will be thousands of users who will want to talk with our backend, our microservices. So then what AWS will do will scale it, up to tens of thousands of instances. And maybe this is the middle of night, nobody's using anything. Everybody are sleeping, there's just nobody, so there's no Lambda and there's no cost. And I guess for most of the startups, this is the most important. Because when you are using servers or containers, whatever, if nobody's using your application, you still have got a server, and you will need to pay for it. This is the life. With Lambda, this is a bit different. You throw the application. This is your microservice, but if you are not using this, there is no cost connected with this. So because there are no servers, a lot of things which usually had to be done by developers or by the company are being now done by the cloud provider. So the scaling, which I already described, and the capacity planning, deployments, you are just throwing your application, your microservice, and it will be deployed across multiple data centers automatically by the cloud. So in fact, you don't need to think so much about building it, to making sure that it's highly available, fault tolerant, because it will be done automatically by the cloud. And like I said this before, with Lambda, for what you are paying is actually the time when Lambda is doing something. So when it's not doing anything, you are not paying for anything. But when it's processing some requests, then what the cloud will do and what AWS will do, it will calculate how much time did it do something. Maybe 2 seconds, maybe 1 hour, maybe 2 weeks in the total, in the sum, so you will pay for this. So Lambda has got a different, so when you have got this Lambda function, it can be executed by different kinds of methods. One of them is that you will use AWS SDK for Java, .NET, Python, and so on. And from your code, you will just say, okay, execute this Lambda function, which I have created before. A different situation, very popular, is that we want to expose this microservice to the world by using RESTful API. So we'll use a different service from AWS, which is called API Gateway, which will make this Lambda being exposed to the world as a RESTful web service. Of course, different Lambda function can also execute it. We could schedule the cron. So we don't need, usually when we would have some kind of script which we would like to run every 1 hour, every 12 hours, we would need to have a server, and we would need to pay for it, all the time. With Lambda, we just, put a script, our microservice in the cloud, and we just specify, okay, dear cloud, run it every hour, every 12 hours, and so on. And of course, there is Alexa, so this artificial brain in AWS Cloud. So whenever we are building, when developers are building some kind of new skills, so functionalities for Alexa Echo, they are using Lambda to build those backend applications. So I said to you that whenever we want to expose the Lambda function to the world as a RESTful web services, we are using API Gateway. And API Gateway is a way for us to define this RESTful definition. So for example, we could say that, okay, there is our domain, www.mypage.com, and we want to define our resource that whenever the user will write v1, people, and some kind of HTTP method like get, post, and so on, our Lambda function should be executed. So maybe there will be a different methods like get, post, put, and so on, and each of them will be connected with different method, different Lambda function. With API Gateway, we can of course also to make different versions. So let's say, for example, that we used to have our Lambda function, which was application 1, but we have modified this, and now it's application 4. So we can make the second definition of our RESTful API, and also new and previous users of our service can use both of them. So if in the past, when we are building these applications using microservice concept, and when we were using servers or containers, now we are just switching to microservices using the Lambda service. So each of them can execute different Lambda function, but if there are no users, because everybody are sleeping, or maybe our application is not so popular, we won't pay for anything. So if we would imagine, a standard web application, we're building a standard web application, we have got a load balancer, we have got some kind of a web servers in the auto-scaling group, we have got, our application layer, again, load balancer, auto-scaling group, and we have got some kind of databases layer. Then if we would like to move it to this Lambda serverless approach, we would just remove the application layer, and we would change it to use API gateway and Lambda. Probably we wouldn't replace the web application, the first layer, so web layer, because usually Lambda is a backend. It can provide a web layer, but usually it won't be the best practice. Also quite interesting and popular approach is that whenever we're building application, a mobile application, so on one hand we are designing an application which will publish on iStore and so on, but on the other hand we need to have some kind of backend. So we could speed up server. No, it's not a problem. In 2-3 minutes we will have got a server, but a different approach is that we'll use this serverless approach. We'll use Lambda, we will expose it to the world as using API gateway, so we'll have got a RESTful services, and we'll consume it in our web mobile application. So it will scale automatically. If there won't be any users, still a lot of startups won't be successful. People won't use those applications, so we don't want to invest in the servers. Sometimes we're building some more complex architecture. One Lambda will execute different Lambda. Sometimes we need to wait a couple of seconds, couple of minutes, before we'll execute a different Lambda. Sometimes we want to make some kind of condition, depending on some kind of parameters. We'll go one way or the other way, maybe go back and then join our executions. So to make it simple, there's also a different service, or a different Lego block in AWS, which is called a step function, which in fact is a way to make a workflow, define a workflow which will define which Lambda, which microservice should run after another. And one of the concepts which often was said that with Lambda function, with serverless, it's really hard to debug. It's really hard to test it locally, and it's really hard to debug how it's working. So, and this is an example of this iterating an MVP process. So when Lambda was introduced a couple of 2 years ago, there was no way of testing Lambda function locally on server, and there were no good way of debugging Lambda. So now it's possible to test Lambda locally, and also there is a service which is called X-Ray, which is there to help debugging the Lambda. So in fact, we will have got a map of each of the Lambda functions which were executed by the user, and also we will have got a track of information, what kinds of inputs there were, how long time did it take, which were the next services which were executed by this Lambda. Okay, I guess this is the end of my time, so I wanted to show you a demo, but I guess we don't have time. Just one small recommendation. So just after this conversation, if you don't have AWS account, just create one and try to build a microservice using the Lambda function. I promise you that it takes 2 minutes to build a microservice. There are no servers. You don't need to think about servers, and it's really a way where companies are going, whenever they want to build quickly new application, new microservices. If any of you will have got any questions, this is my email. Please feel free to write. I'm happy to answer and reply. Thank you.